There's actually no really new material in this section, it's just new notation. And so we're going to start off with, if cosine of theta is equal to x, because remember sine is usually the y value and cosine is usually the x value for absolute values, then the angle theta is the inverse cosine of x. So the first new notation we're going to learn is that cosine inverse is sometimes written as arc cosine. And all of the functions have inverse function. There's an arc sine, there's an arc tangent. So seeing this arc is the same thing as seeing this button right here. And the thing is if you look right here, this is what the calculator looks like when you press the button, but sometimes your problems in the book or your calculus books will be written like that. Really, you have to know that if you see this notation, that you type this in on the calculator. Your assignment will start off with a series of inverse cosine questions, like cosine inverse of the square root of 3 over 2. And you should know that the angle whose cosine is the square root of 3 over 2 is 30 degrees. Which if it asks you to give in radians, you'd want to put out pi over 6. We will be adding problems that you need to do on the calculator. So for example, if you had cosine inverse or arc cosine of 0.24, what this is asking you is find the angle if the ratio of adjacent to hypotenuse is 0.24. You can type it in on the calculator just like it looks, and your calculator might tell you that the angle is 76.11 degrees. But maybe that's not quite the question. Maybe it says that you have to do that problem, but you have to give the angle that's between 3 pi over 2 and 2 pi. So first of all, when you see this notation right here, you need to know that your angle needs to be in radians. So I'm going to switch my mode on my calculator and press the same thing, cosine inverse of 0.24, and my calculator tells me that that's 1.32 radians. So theta is 1.32, but if you think about radians, this is 0, this is, let's see, pi is 3.14, so 3/2 pi is about 4.71, and 2 pi is 6.28. So I need to have something that's 1.32 radians away from 6.28. So what this is really saying is I need to be down here in this quadrant. I need to be 1.32 radians away from 6.28. So I'm going to take 6.28, subtract 1.32, and my final answer is 4.96. I'm going to do one more example like that. This is going to be find the angle if the tangent is 2.84 and we're looking in the third quadrant. So the first thing I'm going to do is get out my calculator and I'm going to type in inverse tangent, because remember inverse tangent and arctangent are the same thing. Inverse tangent of 2.84. And when I do that, I get 1.23 radians. So the angle is 1.23 radians. But this is asking me for an answer that's between pi, which is 3.14, and 3/2 pi, which is 4.71. So it means this answer needs to be over here in this quadrant. It needs to be 1.23 radians past pi. So I'm going to take, and my real answer for theta is going to be 1.23 plus 3.14, so 4.37. You're going to do the math on your calculator, and then you're going to think about, is this drawn in the correct quadrant? And you're going to have to add or subtract from the horizontal. You're always adding or subtracting from either pi or from 2 pi in order to get the angle that you actually want. Next, we're going to up the stakes a little bit more and ask questions like, find the cosine of the inverse sine of 1/2. So what this is saying is this right here is an angle. And you should know that the angle that has a sine of 1/2 is 30. So this is saying find the cosine of 30, and that's the square root of 3 over 2. So the notation is embedded, but you're going to work from inside the parentheses to outside, just like you would do for any order of operations problem in math. Again, on these problems, we're going to go from inside to outside. So the cosine of 3 pi over 4 is going to be negative because it's in the second quadrant. If I look at this, 3/4 pi is right here. This is a square root of 2 over 2 here, negative square root of 2 over 2 here. So the cosine of 135 degrees is negative square root of 2 over 2. So now the next part of the question is asking, find the angle if the cosine is negative square root of 2 over 2, and that angle is 135 degrees. Now the thing is, these aren't always going to be the same, because sometimes they'll say, well, we want your final answer between pi and 3 pi over 2, and if that's the case, your answer is going to have to be 5 pi over 4 instead of 3 pi over 4. So again, pay attention to where they want you to give the answer. Now, if they don't actually tell you where to give their answer, there are some rules for these. If you're doing an arc sine function and they don't tell you what quadrant to give your answer in, always do it between negative 90 and 90 degrees. If they give you an inverse cosine function and they don't tell you where to give the answer for that one, you're always going to give the answer for cosine between 0 and 180 degrees. And if they do not tell you which quadrant to give the answer for tangent in, for tangent you're always going to give the answer between negative 90 and 90. These are hard and fast rules. You might have to memorize them. I think of it, basically you're giving the answer for sine in the two quadrants where sine is positive and negative, and you're giving the answer for cosine in the two quadrants where it's positive, negative. So by picking these numbers, you always get the quadrant that has both the positive and negative values. So then things will get a little bit crazy on you, and you're going to have to use algebra, and this is the last 6 questions on the homework assignment. It's going to say things like, find the sine of the angle whose cotangent, oh actually let's do cosine because it's with the wrong letter, of the angle whose cosine is, let's say x, 1 over x. Let's do that. So the angle whose cosine is 1 over x. So first of all, I'm going to draw that picture. Cosine is adjacent over hypotenuse. So they're wanting me to have the hypotenuse be x, and they're wanting me to have the adjacent side be 1, and I need to find out what y is. And so I know that 1 squared plus y squared equals x squared. So I know that y squared is equal to x squared minus 1. And so I know that y equals the square root of x squared minus 1, which by the way is not x minus 1. You have to stop there. And although this could be plus or minus, because I'm going to keep my picture in the first quadrant, because the sine and cosine aren't positive and negative in the same quadrants, I'm just going to stick with the positive answer. So now I know that this side is the square root of x squared minus 1, and I can answer my question. So this is the angle theta. So I'm finding the sine of this angle. Notice the cosine is adjacent over hypotenuse, 1 over x. So the sine is going to be opposite square root of x squared minus 1 over x. And this guy up here, that's your answer. So draw the picture, label the triangle, figure it out. So we're going to do this 2 more times, once with letters and once with numbers. Let me do one with numbers. Let me think. Let's find the sine of the cosine inverse of 5/13. Okay, so what this is saying is it's saying to find the sine of the angle whose cosine is 5/13. So we should probably draw a picture first. The cosine is 5/13. It's saying the hypotenuse is 13 and the adjacent side is 5. And if you're good with geometry, you have that triangle memorized. And if you don't have that triangle memorized, you need to bust out Pythagorean's theorem. 5 squared plus x squared equals 13 squared. A lot of you got a problem similar to this wrong on the quiz because you didn't do order of operations right. This is x squared equals 144, and so x is equal to 12. I'm going to keep it in quadrant 1. This is 12. So this is asking me to find the sine of the angle whose inverse cosine is 5/13. And the sine, since sine is opposite over hypotenuse, the sine would be 12/13. Last example is the same thing, but this time we're going to use letters. Find the sine of, let's see, find the sine of the sine inverse of 2x. So this is saying find the sine of the angle whose sine is 2x. So we're going to draw a picture. And since sine is opposite over hypotenuse, it's saying that 2x over 1 is opposite over hypotenuse. So it's saying we've got a hypotenuse of 1, we've got an opposite of 2x, and I need to find nothing. I don't even know why I'm doing this. Sine and sine inverse are the same angle. This will just be 2x. But if I had to do something fancy, like find the cosine of the angle whose sine is 2x, then I would actually need to draw the triangle and figure out how long this side is. And this side, if you bust out Pythagorean's theorem, is going to be the square root of 1 minus 4x squared, which again is not 1 minus 2x. You can't do that kind of thing. And so the cosine would be the square root of 1 minus 4x squared over 1. Homework assignment will be all inverse trig functions, and your quiz that has story problems on it will also have inverse trig functions.